Good morning. We will start session 3 on chapter electricity. So in our previous session we understood about how to connect, derivation for series and parallel connection. We also understood in brief about what is series connection and what is parallel connection. Now let's see the advantages of parallel combination or parallel connection over series combination. Now basically what will happen is, in series connection, if one component fails, that means the circuit is broken at that particular point, and the remaining components, what will happen? In series combination, if one component fails, that means the circuit is broken. What will happen to the remaining components? That will also stop working. But over parallel connection, when we talk about, if one component fails, only that particular circuit is broken. Remaining will work finely. Best example what I can give you here is the lightings what you use in Diwali and all, those are series connection basically. Nowadays an advanced things might have come up, but still the basic thing what we use there is a series combination. If the one of the lighting fails, the whole arrangement fails. Parallel combination, it's not like that. That means what connection is suitable for our household things? Parallel connection is, our parallel combination is suitable. Why? Because if one component fails there, only that component stops working. Remaining will start with its own thing how it is working. That's one point. Second one point what we have to understand here is, in series, since the current drawn is same throughout all the resistance, that means a particular appliances might not require that much of current to run, right? But since it is in series connection, throughout the circuit the current runs the same. That's a disadvantage for us. So what if your refrigerator, what if your tube lights also will run with the same current what your refrigerators and AC also running, right? So in parallel combination what will happen is, a different current runs to different system, different arrangement of the resistance. So current varies according to the utilization what you talk about. So remember, our household circuit connection is a parallel connection. That means we don't use series connection anywhere at home. We use. There is a point or there is a part where we use a series connection at home. It is in the electric fuse. What is electric fuse and why we use that, we will understand later. So basically, advantages over parallel combination over series combination, as I have discussed, the points are mentioned in the notes, you can as well go through. We go to the next concept, that is heating effect of electric current. Now, see, whenever electric current is passed in the given thing, there are different types of effects which are created. Chemical effect, heating effect, magnetic effect. So here we are studying the next chapter. What we have is about magnetic effect of electric current. When electricity is passed in a conductor, magnetic field is generated. That is something called as magnetic effect of electric current. When I pass electric current in a conductor, heat is generated. That is heating effect of electric current. What it is actually, let's understand. So imagine that I have given a conductor. So if you assume that always why the conductor is so big, see, conductor when I mean to say a wire. I just zoomed the wire to make you understand. So this is connected to a source, a plug key, right? Plus, minus, current is flowing and electrons are moving in this direction. So the current is flowing in this direction, electrons are moving in this direction. So electrons are negatively charged, right? So current is flowing here means, so this is plus and this is minus. So electrons are moving here, it is all getting deposited. Then once the current flows, it starts moving, collision happens, all this thing. Then what is this heat generated here? Now, if I give you a simple example, a bullet which is fired. So a bullet when it is fired, because a bullet has a very high velocity, right? So which has nothing but its kinetic energy is very high. So when a bullet strikes this wooden log, it penetrates the wooden log, and what happens actually here? Fumes come out, right? You can see. So why is this coming out? Because, see, we know, because law of conservation, energy is neither created nor destroyed. It can be only converted to one form of another. Kinetic energy of this is converted to heat energy. That is why we can see heat generated there, right? Energy from one form is getting converted to another form. That means more and more is the kinetic energy, more and more is the heat generated. Now here also if I have to talk about, if I want to generate more and more heat, that means what I have to do here. So for example, resistance is directly proportional to length and inversely proportional to area. So if I have to generate more and more heat, more and more resistance should be there, more and more, the longer the length of the wire should be there, area of the cross section should be less. That is why if you see in almost all the heating appliances, children, the wires are always like this form, right? It's coil form and it is very thin. Why it is very thin? Resistance is inversely proportional to area, directly proportional to length. I want longer the length of the wire, longer the length, longer the resistance. Longer the resistance, longer or higher is the heat energy produced. So here what happens, see, basically take tungsten also if you take, right, filament, it's very thin, it's coiled. Why it is coiled? Because any electric appliances, see the wires inside or anything, the coil inside the electric appliances is always coiled. That's why we call it as a coil. Why it is coiled? Because we want, I can't put such a long wire in the coil, correct? That means I have to wound it to make it small and as thin as possible. That is area of cross section as smaller as possible so that I can increase the resistance. Now that means heat is getting increased. What is this heat, children? Heat is a form of energy. What is energy? Energy is capacity to do work. All are interrelated. Heat energy is generated, that's nothing but it's a form of energy. Now what is energy? It is a capacity to do work. That means if heat energy is generated, some form or the other form work is said to be done. Now how do I derive an expression for this heat energy liberated by a conductor? So if I just check here, heat is a form of energy and energy is capacity to do work. Do we have any formula based on work relating to heat, energy or anything in this chapter? Yes. What is that? So I'll just erase this. So heat is nothing but, I'll again just write here, heat is nothing but form of energy. Energy is capacity to do work. So if you remember, potential difference is nothing but work done in moving a unit charge from one point to another. Potential difference formula, V is equal to W by Q. Yes, we know that current is equal to charge by T, right? This implies Q is equal to what I can say, IT. So I'll write this as W is equal to VQ. W, I will write this in the form of H. Why? Because heat is a form of energy, energy is capacity to do work. All are interrelated here. H is equal to V, where Q is written as IT. This is one formula for heat energy produced. When calculate the heat energy produced by the given conductor, if voltage is given, current is given, time is given. This is one formula. I can derive several other formulas from this. Let's see how. See children, your derivation is not asked in the exam. This is only for your reference, already alive and writing it here, which you should know. What is asked? What is heating effect of electric current? A definition can be asked. Based on heating effect of electric current, there is another law that is usually asked, a very important. Applications of heating effect of electric current. What are the applications? Based on there are some questions that can be asked. Numericals on this will be asked actually. But how did we come to this equation? That's more important for you to understand rather than just sitting and by hearting. Oh, it's given in the textbook. H is equal to VIT, where sometimes you'll also forget the formula. How did you get it? But if you know the concept one form of finding heat energy or heat liberated by a given conductor. Let's see few more. Again I will write the same thing. This is first one, children. H is equal to V I T. Suppose we know that later we'll write next one. We know that V is equal to IR. So H is equal to IR and IT, right? So H is equal to I square RT is the second formula for heat energy. When current is given, resistance is given and time is given here. Sometimes time, or you can also say yes, you can consider this as time only. I will write this as T. Okay. One more formula we have now. Again I will write the same thing. This only I will write H is equal to V I T. Again same thing. We know that V is equal to I R. So what we will do here is, instead of I we will substitute now. So I is equal to V by R. Okay. So H is equal to V. Instead of I, what will I write here? I will write V by R into T. So H is equal to V square T by R. Okay, this is another formula if I do voltage, time and resistance. That means we derived three different formulas for heat here. In that, this one is very important. That is H is equal to I square RT is also called as Joule's law of heating. Definition. What is Joule's law of heating? Looking at the formula, if you remember the formula, I can write the definition. Joule's law of heating states that the heat produced by the resistor is directly proportional to the square of the current, directly proportional to the resistance across the conductor, and directly proportional to the time, what you can say here. That's the same thing what I have given in the book. It's given in three forms here. Directly proportional to the resistance, directly proportional to the time for which current flows actually mentioned. So, yeah, time, correct. And the resistance. What is Joule's law of heating? Explain this. You have to first write Joule's law of heating states that the heat produced in the conductor is directly proportional to the square of the current, directly proportional to the resistance across the conductor, directly proportional to the time what the current is flowing, or yes, in the conductor. Then give the relation. Oh, you get marks. A very important question. Numericals can be asked on any form, provided you should know what to apply when what is given, right? So these are the three derived forms of the heating effect of electricity, what I can tell, how to check the heating effect of a given conductor. Now, what are the applications if I talk about here? One of the application is electric iron, so that works on the heating effect of electric current. So the second example is your bulb. So very rarely we get to see those bulbs nowadays because they are all replaced by LED tube lights and LED bulbs, right? So here when I talk about heating effect of electric current, children, it is not about your LED bulbs, right? So I think you might have rarely seen such bulbs, but make sure that you go to any what you can say is grocery mart, any store, ask for a bulb, not the LED one, but the bulb which comes with a, what you can say, a carton cover, right? So which is transparent to look like, you might have seen. Or make sure that when you see that bulb, you can also see the tungsten wire in the bulb, right? What is this tungsten? Tungsten is a filament which is used in the bulb. So there are some properties what we have to understand about the bulb and about the heating effect of this bulb. So when I talk about heating effect of electric current, so electric bulb is the best example. So a filament tungsten, the symbol is W, is used in the bulb. Why filament tungsten is used? Why can't we use copper? Why can't we use anything else here? That's the only reason, because now see, what is the main purpose of electric bulb? Now those bulbs along with light, they also produce more heat, children. Comparatively, I don't think your LED bulbs or tube lights produce that much of heat, because you start feeling hot when you're sitting under that bulb actually. So it also consumes more power. That is again secondary. So let's come to this. The filament tungsten is used. So usually basically when we talk about, right? So this is how the tungsten will be. And the fun part is when the bulb goes off, you actually come to know that this tungsten is actually broken. It's like a loose wire which is falling, you can feel that, right? Try to get this experience actually. But the same thing when your LED bulb goes off, you can't see all those things in that. It's a translucent, right? But this is transparent. So what happens in this tungsten? Again, electricity is required. It only works with electricity. When we pass electricity in this, so what you can say, this tungsten gets heated up. This tungsten gets heated up so very much that it starts producing light, right? That is why tungsten is used as a filament. It starts producing light. Then that means that tungsten is getting heated up so much. Then why don't that tungsten wire melts off? Now anything if it is getting heated, definitely it will melt off. Tungsten wire has a very high melting point. Approximately around 3008 or 3000, not required, approximately around 3000 it has. So it has a very high melting point. So amount of heat generated is not up to this much also, because it can withstand up to that much of heat. So with that much of heat, what happens? It lights up. You get a bright light. Along with that, there are some gases filled in this. We use argon as an inert gas. Now what are inert gases? You studied that in the periodic classification. So we use argon as an inert gas in this bulb actually. Why? Because if in case the tungsten comes in contact with the oxygen, what will happen? It will form its respective oxide. Tungsten oxide will be formed. That means magnesium coming in contact with an oxygen, what will happen? Magnesium oxide will form, right? A chip of layer, we have to brush it off and remove it. So tungsten should not come in contact, that is tungsten should not get oxidized. That's the only reason we fill this with a particular gas, that is argon, what you can say. So this is about one of the application of heating effect of electric current. So when it gets heated, due to very high heat produced, the tungsten gets lighted up, right? So now if it has a very high melting point, then why don't we use it in wiring, children? Because if you use it in wiring, your electric wires will start glowing actually. So we don't use tungsten in electric wire. Because what is the purpose of electric wire? It serves the purpose of flowing of the electric current from whichever appliances we want, the connection it reaches, right? That is our purpose. We use copper wires there. Here our purpose is for the light. That is why we use tungsten here. So yes, and another one thing what I have to tell you about is which material produces very high resistance or heating effect is more in that. More than metal, alloys offer high resistance, or you can say alloys offer high resistivity. The materials which offer high resistivity has high resistance. Remember this one point. Next point what we have to discuss here is electric fuse. What is electric fuse? Electric fuse is a device which is used, we basically use this in our main circuit connection, in our housing circuit what we have, but nowadays it is replaced by MCB, miniature circuit breaker, where a different phenomena works on this. A fuse also is there, but most of the time we use this. Usually basically fuse is a device. What happens in fuse is, now what happens, we have a electric meter, so that wires come from the what you can say, from the lines, from that meter that comes to our house, right? So if there is any high current which is flowing in the circuit, what will happen, that high current will flow in our house also. Our appliances might burst, destroy, because of the high current which is not required. It only requires a particular voltage with respect to the current. So what will this electric fuse do? Whenever the high current flows in it, it will break the circuit, because electric fuse has a very low melting point. It can only withstand to a particular current, what you can see, particular heat, what you can see. So the minute it cannot withstand the current which is coming through it, it's very high, it will cut off the circuit. Once it will cut off the circuit, it will not allow the current to flow through your house. That means, how should I connect electric fuse with my connections to my home? Should I connect this in parallel or should I connect this in series? To all, assume that this is one board. Through this board, all the connections will go to your house, right? This all the board wires, assume that, is connected to a fuse, electric fuse. This wire with electric fuse should be connected in series or parallel, children. It should be connected in series. Why? Because what will happen in the series? If one line cuts off, the whole thing cuts off. If this was in parallel, what would happen? Only one way, one appliances would be saved, remaining appliances would be gone. So electric fuse is always connected in series. Now again, this is a very brief explanation what we have here. You again have a bit in detail about this in the next chapter, magnetic effect of electric current, where we study about domestic wiring. Then again we study about this a bit in detail there. So here let's only understand what is the meaning of an electric fuse. It has a low melting point. So I've given some points in the notes also, that it's a safety device that protects our electric appliances in case of short circuit or overloading. So a fuse is made up of pure tin or alloy. So it's always connected in series with live wire. What is live wire, neutral wire, earth wire? You will study that in domestic wiring in the next chapter. The last part, that is electric power. So what is power? The rate at which the work is done is called as a power, what we can say. That's the definition. We have some, what you can say, small derivation, some formulas with respect to power. Power is nothing but we have to study. That's how we calculate our electricity bill, children. It's all related to that. So what is power? The rate at which the electric energy is consumed. The rate at which electric energy is consumed. So I can say that power is equal to rate at which electric energy is consumed. So this is definition, this is the derivation, or E is equal to P into T. Electric energy is consumed given by power into T. So there are some other formulas also what we have here. So when we talk about a power, or what you can say is SI unit of power is watt, denoted by W. Then commercial unit of electric energy, when we talk about it is kilowatt hour. We write that as kWh. So one few terms what we have which you should remember. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. This you should remember here. So which is nothing but 1 unit of electric energy. Our electricity consumed, we say that 1 unit. So have you ever seen your electricity bill, children? Number of units consumed in a month, 30 units, 20 units, 15 units. What are these units? They are in terms of kilowatt hour. You all can see how many units are consumed in your home in a day. So go and see your electric meter. Read the units. If it is a digital meter, you will get to read the units. Suppose today your units read, then there is a number. Say 3926 is a number. In terms of kilowatt hour, it is mentioned at that point of time, right? Note the time. at today you can say at 10 a.m. the reading was 3926. Probably tomorrow at 10 a.m. exactly, when you go and see, it will be 3930 it is. Assume that kilowatt hour. That means from yesterday morning 10 a.m. to today morning 10 a.m. or exactly in that one day, how many units were consumed? So 26, 27, 28, 29, 30. So 4 units were consumed. Okay, sorry, from 26 to 30, you consumed 4 units. It's not you, your appliances at your home. So that is how electricity board meter person, when they come and take the electricity bill, it is measured in that form. To observe, read the units, how it is calculated. You are going to do the same thing here in this chapter by calculating how many units are consumed, how it is calculated, what is the power generated. All these things you will be learning here. There are 2-3 formulas, children. That is the last concept of this with respect to power when we talk about. So few more other forms of formula if I have to write about this is, just see here, we'll again take the same thing. Power is equal to, that is rate at which the energy is consumed is called as power. So we already know that energy is a form of, or heat is a form of energy. Energy is capacity to do work, right? So I will write here P is equal to W by T. So again we know that where W formula, where it will come, children. So V is equal to W by Q. This implies W is equal to V into Q. So I will write now P is equal to, instead of W, V into Q by T. So here I will write again. We know that I is equal to charge by time. So what is Q? Q is equal to IT. Substitute. P is equal to V I T divided by T. So P is equal to V I. See, derivation is only for your reference what I have done. That means power is equal to voltage into current. When a voltage and current is given, if I ask you to find power, how should you find? This is the formula. Again here you can change the things. V is equal to IR. Ohm's law, what we know. So power is equal to IR into I. So power is equal to I square R. Can I write this? Second formula. Then instead of I will substitute now again. So how many formulas we know? This is 1, this is 2, then this is 3, this is 4, one more. Again for V is equal to IR. I will write here V is equal to IR. So instead of I will substitute now. V by R is equal to I. So P is equal to V I will write as it is. Instead of I will write V upon R. So P is equal to V square by R. So these are the different forms of formula when to find a power when voltage and resistance is given, when voltage and current is given, when current and resistance is given, when energy consumed and time is given. So you should know all the things how to find, same as how we calculated for heating effect of electric current. So with that we complete the chapter electricity with all what basic terms and things what we know. We have numericals based on the things on this applications what we have studied, which we will be doing it in the consecutive sessions.